Next is random access memory, chapter 8.4, RAM. What is random access memory? Random access memory is a form of computer memory that can be read and changed in any order, typically used to store working data and machine code. A random access memory device allows data items to be read or written in almost the same amount of time, irrespective of the physical location of data inside the memory. So RAM is a memory where you can read and write. Then the difference between RAM and ROM is a read only memory, and RAM is share with you. So the overview of RAM: any memory address location is easily accessible as any other. It is used in computers for the temporary storage of programs and data. You can relate with the video just now. Disadvantage: it is volatile and will lose all stored information if power is interrupted or turned off. Advantage: can be written into and read from rapidly with equal ease. There are a few types of RAM. Static RAMs is divided into two main categories: static RAMs, SRAM, dynamic RAM, DRAM. Under the static RAM, there are two types of static RAM: asynchronous static RAM and also synchronous static RAM with burst feature. For the dynamic RAM, fast page mode, DRAM, extended data out DRAM, burst ADO DRAM, and synchronous DRAM. So there are a few types of random access memory. This figure 7-2 is the functional behavior of a RAM cell. A static and B is dynamic RAM. So this is how the logic gate of the RAM looks like. For the static, you can see it is used a logic gate, and for the dynamic, it is used a resistor and also capacitor. For the static RAM, SRAM, the characteristic of the static RAM, it can store data as long as power is applied to the chip. If there is no power, you cannot store the data. Each cell is basically a flip-flop. Each memory cell is basically a flip-flop. Very simple interfacing, writes and reads at the same speed, very fast, access times under the 10 nanosecond available. It consumes a lot of power, poor density memory available. So that is the characteristic of static RAM. So this is the logic circuit for the SRAM. You can see here the address line input and the output, data input and output. And then this is the input chip, write, read, and also output enable. And this is the internal architecture of static RAM. So address lines, row decoder, memory array, 8 bits, input data control, column I/O, column decoder, output data. So SRAM operation, so read cycle sequence, a valid address is put on the address bus. CS, chip select is low. You can look at the logic circuit here. There is a chip select is low, output enable is low, data is placed on the bus. So this is the example of read cycle for the static RAM operation. For the write cycle sequence, a valid address is put on the address bus. Chip select CS is set to low. WE enable, write enable is low, data is based on the data bus. So this is the sequence for the write cycle. So next is a dynamic RAM. This is another type or categories of the random access memory, dynamic RAM. So the characteristic of the dynamic RAM, it has a high capacity, low power requirements, moderate operating speed. It employs capacitors to store electric and charge, whose level represent 1 or 0. Capacitors dissipate with time and hence the charge must be restored frequently. So this is the logic symbol of circuit of the DRAM architecture. Cell arrangement in 60K multiplied by 1 of dynamic RAM. So you have the decoder 1 of 128 decoder for the column address input. So this decoder can be used to select one of 128 columns. And there is another decoder 1 of 128 for the row address input. And this is the memory cell for the DRAM architecture, 128 columns and 128 columns. Figure 12-26, symbolic representation of the dynamic memory cell during write operation. Semiconductor switches SW1 and SWT are closed. During a read operation, all switches are closed except S1. So this is how the write operation for the dynamic RAM. The switches S1 and S2 close during read operation. All switches are closed except SW1 for the read operation. For the write operation, SW1, SW2 close. For the read operation, SW1 is open. So this is how the DRAM operate. If you want to write this to the DRAM, this is the write cycle sequence. Switches S1 and S2 close, while S3 and SW4 is open. SW1, SW3, and SW4 are open. So disconnect the input data to capacitor C. Connect the input data to the capacitor C. A logic 1 add the data input charge to C, a logic 0 discharge it. Then the switches are open so that C is disconnected from the rest of the circuit. So you can write the DRAM. So next is a read cycle sequence or for the DRAM operation. Switches SW2, SW3, and SW4 for close. You close the SW1, W2, 3, and 4, and 1 is open. Then connect the stored capacitor voltage to the sense amplifier. Okay, the sense amplifier compares the voltage to determine if it is a logic 0 or 1, and it produces solid 0 volt or 5 volt for the data output. So this data output is also connected to C. SW2 and SW4 are closed and refresh the capacitor voltage by recharging or discharging. So this is the sequence operation for to read for the DRAM memory.